Hey guys, I'm Pat Kelly. Okay, in this problem, they really just start us off with these 3 points in 3 space, and the directions are to find the general form of the equation of the plane that would pass through those 3 points. And what else I've written to kind of get us a little bit started here is the standard form for the equation of a plane in 3 space. And one of the reasons I do that for you is you're actually going to end up using this form a lot, this standard form, but let it guide you in terms of the work that you need, so I know how to even get started on this problem. So what I mean by that is, what pieces of the puzzle am I going to need to plug in? And you can see here's x1 and y1 and z1. So you need a point, but that's easy because they gave us 3 points and I can choose when I'm ready for it. A little bit tougher is you also have these pieces of the puzzle, A and B and C. And you need to know that those are the components of a vector that would be normal to this plane. Okay? Any vector that's normal to that plane. So that guides me and gets me thinking, I need a vector that's normal to this plane. How am I going to do that? Well, we have a great tool for that, the cross product. Right? So what I'm going to do is find 2 vectors that are in this plane and take the cross product of those vectors. That resulting vector will be normal to the plane, and then I'll have my A, B, and C, and I'm going to be ready to plug and chug. Okay? So 2 vectors that are in that plane. They gave me these 3 points, and for a quick bit of bookkeeping, let me get some names on these guys, A and B and C, because vectors that will be in that plane then is really just any kind of pairing of those. So I'll grab A, B, and I'm going to write it as a vector. And when I'm ready for it, I'll also do A, C. Those will be my 2 vectors in the plane. I'll do my cross product, and then I'm going to be good to go. All right. So getting these vectors, you've done this before. A, B, you grab your terminal point, that's the second letter there, B, and subtract the components respectively with the other points. So 2 minus 3 looks like a minus 1, comma, 3 minus 1 is a 2, and 4 take away 2 is a 2, and I'm writing that in component form. So I'll put my little triangular braces on there as well. AC equals, same kind of work, minus 3 take away 3, looks like minus 6. 4 take away 1 is 3, and 2 take away 2 is 0. All right, now again we did that because with those 2 vectors that we know are in the plane, if I do the cross product, I end up with a vector that is orthogonal to both, and in this case that means normal to the entire plane, so we're going to be in good shape. Now finding our cross product, usually our approach here, a very useful, convenient approach, is this determinant form where the top row is ijk, the middle row is going to be these components, minus 1, 2, 2, and the bottom row will be these components, minus 6, 3, 0. Okay, and then we evaluate that using our cofactor expansion approach, which means I have the I vector that is going to multiply by the determinant of the submatrix right here, 2, 2, 3, 0. 2, 2, 3, 0. Minus, that subtraction is part of your cofactor expansion work. And the submatrix this time looks like minus 1, 2, minus 6, and 0. And then finally for this step, you have your k vector that is going to multiply by the determinant of this submatrix here. So minus 1, 2, minus 6, 3. All right, let's do that work. If I slip down here, this work is going to be your crisscross work. So 2 times 0 is 0, minus 2 times 3 is 6. That'll be my I component. Minus, here's another 0, subtracting with a negative 12, so let's make that plus 12. j plus negative 3 crisscross. I'll do a minus 12, so plus 12k. All right, let's go one more step, and this time I think I'll go into my component notation and just grab minus 6, comma. This looks like 12, but don't lose the minus sign outside, minus 12, comma. And this looks like 9. All right. So this vector is that cross product, and more importantly for me in this problem, that vector is normal to the plane that we're looking for. So I can go up to my standard form, and for my A and B and C, those pieces of the puzzle I was looking to plug in, I can use minus 6 and minus 12 and 9, respectively. Okay? So switch colors if you want. I'm now looking at this standard form, right? My A is going to be minus 6, parentheses, x, subtract. The x sub 1, I mentioned earlier, it's your pick. Any one of these points that you want, A, B, or C. I'll grab the top one. So I have 3 for my x sub 1, plus b, but I'm looking ahead. Looks like my b is actually a negative 12. So let's do subtract 12, parentheses, y minus the y coordinate of that A point, 1, parentheses, and then plus, I'm still looking at my standard form, look at it like a formula, plus c, and my c is 9, parentheses, z minus, and I need to grab my z coordinate of 2. And as part of this standard form, there's equals 0, so equals 0. And now I'm going to distribute, in a little bit of algebra here, minus 6. And as I distribute, I'm going to go ahead and group my variables together here. So I'll skip this minus 6 times the minus 3 for a second. And then minus 12y, oops, minus 6x. I don't know if I said it, but I didn't write it down. Minus 6x, and then minus 12y plus 9z. Now let's go back and grab those constants. That would have been a plus 18. This looks like a plus 12. And this looks like a minus 18 equals 0. And that works out for me that I can add 18 and subtract 18. Those will go away. So then I'm looking at minus 6x minus 12y plus 9z plus 12 equals 0, which is decent, a decent answer. But I'm going to clean it up a little bit since I'm recognizing everything as a multiple of 3. Let's divide a 3 out of there. And I think I can do even better than that and divide by a negative 3, just so that leading term is positive, has a positive coefficient. So divide by a negative 3, and that makes this a positive 2x. That makes this a positive 4y. That makes this a minus 3z. And that makes that a minus 4. And it makes the 0 a 0, no change there, right? That's my answer, all right? General form. Good. Practice them on your own.